Hi guys, today we are going to discuss classical free electron model. But before that, I want to mention that I had already uploaded a lecture on the difference of Maxwell-Boltzmann statistics, Bose-Einstein statistics, and Fermi-Dirac statistics. And also a lecture on the effect of temperature on the Fermi-Dirac distribution function. And link is given in the description. So I suggest you to first visit those lectures because they help you a lot in understanding in our today's lecture. So in our today's lecture we will discuss two models. First is Drude free electron model and second is Lorentz free electron model. These two models are also known as classical free electron model because they treated electron as a classical particle. As we know that Thomson had discovered the electron in 1897, which enabled Drude and Lorentz to formulate a model to explain two of the most striking properties of the metallic state, which are conduction of electricity and heat. And in our today's lecture, we will discuss both successes and failures of Drude free electron model and Lorentz free electron model. So first we will discuss the Drude free electron model. The following are the assumptions of the Drude free electron model. The first assumption is that the kinetic theory of gases can be applied to Drude free electron model. Or we can say that Drude relates kinetic theory of gases to his model. The second assumption was that all electrons have same thermal speed. He also assumed the free electron approximation, that is, he ignored the electron-phonon interactions, that is, the ion cores which are positively charged do not apply any force on electron. He also assumes the independent electron approximation, that is, he also ignored the electron-electron interactions and simply saying that electrons do not apply any forces on each other. His fifth assumption was that electrons obey Newton's laws. And he also assumed the energy independent relaxation time. As we know that relaxation time is denoted by tau and is the time between two collisions and is also known as mean free time. So according to Drude free electron model, the relaxation time is independent of the kinetic energies of electron. Drude free electron model successively explain Ohm's law, conductivities, that is Weidmann-Ferencz law, and he also explains the Hall's effect. In Hall's effect, in the absence of magnetic field, the electrons move from the negative terminal of the battery toward the positive terminal of the battery without deflecting. But when we apply magnetic field, electrons follow a curvy path and they get deflected. This is known as Hall's effect. The failure of the Drude free electron model is that it failed to explain magnetoresistance. Here magnetoresistance means that when Hall effect is produced in a metal, its electric resistance increases. This is called magnetoresistance effect, which Drude free electron model failed to explain. And after Drude free electron model, now we will discuss Lorentz free electron model. Lorentz accepted all the assumptions of Drude free electron model except that the electrons do not move with the same velocity. According to Lorentz free electron models, electrons are classical particles and that's why they obey the Maxwell-Boltzmann distribution law. So the velocities of the electron could be determined according to Maxwell-Boltzmann distribution law. He also said that most of the electrons have velocities in the mid-range. That is, all of them do not have the same velocities. And according to Lorentz free electron model, he assumed the energy dependent relaxation time. That is, relaxation time depends upon energy. He also assumed that AC conductivity, DC conductivity, Hall's effect all are temperature dependent. and that's why forces for less and high speed electrons are different. The defects of these classical models are that they fail to explain the heat capacity of free electron gas. The heat capacity measured by these two classical models is 100 times greater than the actual value. They also fail to explain the thermoelectric effect and Seebeck effect because they do not involve quantum mechanical effects. Drude and Lorentz free electron models are classical models and based on the classical theory that the electronic density of states would be same as the gases. And according to these two models, the statistical properties follows the Boltzmann distribution because they treated electron as the classical particle. But the fact is that electrons are fermions and they follow Pauli exclusion principle. That is, particles with half integral spin are called fermions and they follow Fermi-Dirac statistics. And in Fermi-Dirac statistics, we have partial distribution partition function, that is z is equal to pi summation ni is equal to 0 1 e raised to power mu minus sigma summation I into kt, where summation I is the ith energy state and ni is the number of electrons in ith state. And this is the Fermi-Dirac distribution function, which is Fe is equal to 1 divided by e raised to power e minus mu into kt plus 1. So this was our lecture on classical free electron model. Hope you guys like it. Thank you very much.